Good morning. I have been assigned with this impossible task to talk about IoT research and development in Brazil. It's simply impossible because I don't have all information about research and development in Brazil, and if I had, it would be impossible to talk about this in 20 minutes. So I decided just to provide an overview from three research institutions. I'll talk a little bit about the Mosaic project, a modular event-based system for pervasive computing in healthcare environments that is being developed by the Catholic University in Rio Grande do Sul. Then I will give you an overview about what is being done by CPQD, the research center from Telebras, and they call IoT the third wave in communications revolution. And finally, the vision from University of São Paulo with our activity called iRiot, Interdisciplinary Research for the Internet of Things. And my idea here is to provide you with some information that come from different institutions to see how they share concepts, what is different, and what are the main tracks of research and development here in Brazil. So about the Mosaic project, this is interesting because Philippe has just told you that there are people that talk more about objects, technology, and this is the view from the people from PUC. They call this Internet of Things. But when they talk about the manipulation of data, they call this the Web of Things. And they are acting on both sides of this development. The focus of this research is healthcare. And when we talk about healthcare, the main point is that there is a high heterogeneity of services and medical devices. And the particular requirements, wide array of heterogeneous and interconnected devices, equipment, several systems and services based on real-time constraints, quick responses to patient clinical changes, intercommunication between monitoring devices and medical staff, need for optimization of network resources, reducing communication costs, and remote services for remote critical care assistance in ambulances or hospitals. What's interesting here is that we have the fusion of IT research areas with different skills. From one side, we have RFID middleware systems and CEP. CEP is complex event processing based software frameworks, and also autonomous models and platforms to integrate and manage heterogeneous devices. And this is necessary to create a system architecture focused on healthcare environments. And these models, they have two parts, one low-level and one high-level parts that will determine different levels of abstraction in the structure of the architecture. So in the low-level part, you have here the proposed architecture of them. And the low-level part is this one, and this low-level part deals with the management of the devices. It's just above hardware and operating systems, and this is where they are developing their pervasive applications and coordinating the exchange of information and data between the devices. In the high-level model, the high-level model is introduced here. And in this case, you have different environments or applications that are producing events, complex events. And it is necessary then to manage these different events to have a global optimization. This is the general view. So On the right side, you see that there are 3 integrated layers: a physical layer, middleware layer, and information management in the integration layer. In terms of architecture style, use design principles of distributed systems and a common framework offering different ways to use the architecture, and also an information model with different levels of data enrichment, and each abstraction layer aggregates some kind of information that is used to trigger specific rules in diffused logic. They are also working with the EPC global standards that it has to be extended for EPC network elements and to deal with DROS and the CEP engine. So the idea here, for me, the most important point is this decision to break the architecture in 2 levels to deal with different aspects of the problem. The view from CPQD Telebras, that's a research more in the track of the future Internet. The Internet of Things is seen as the 3rd wave in communications revolutions. The motivation comes from the fact that the Internet is a big success. The number of users is increasing very much year by year. And in terms of hosts, the Internet today has 575 million host computers, and an expectation that in 2020, 50 billion of connected devices and 50,000 billion of things potentially indexable and interconnectable. This leads to another view of the Internet, or a new proposal of a future Internet architecture that is this triangle. And this triangle has at vertices the user-centric, the content-centric, and the object-centric. And to create and extend one of the objectives is to create and extend the awareness of the environment. For me, this is an important slide because it shows how the network is. The network of the future will be highly heterogeneous. So how can we optimize the applications and service using these resources that are available? Another point is the recognition of the famous hourglass. This can be seen or understood as an hourglass, where we have the IP protocol as the main point of this structure. And why this is important? Because when we recognize this, we see that IP protocol limits the performance of what we can get. Everything depends on IP. On the other hand, it also shows us that the IP provides the convergence. We can have all applications running thanks to IP over any kind of available technology. It also shows that the IP network is not simple at all, and that the IP protocol had to be extended with several other protocols in the control plane. What are the architectural problems? Loss of transparency, scalability problems, incompatibility among protocols. Protocols taking roles for which they weren't originally designed. Security vulnerability and attacks, and new layers have been added between the existing ones. So they propose to rethink the Internet. In this slide, it's important to see that Internet of Things for CPQD is one of the possible scenarios. You have the Internet of People, Internet of Content, Internet of Things, with these required attributes, mobility, capacity, security, that will lead to new architectures. And considering different scenarios, each of them have different requirements or attributes, and the question to be answered, we will have a unified architecture to the three scenarios or multiple architectures. So the focus of this research is this study about the architecture of the future Internet, and that the Internet of Things is one possible scenario. And when we consider the information-centric networking, we have changes of paradigms. Send and receive become publish and subscribe, sender-driven to receiver-driven, and so on, as you can see in this slide. And now we arrive at the research that is being done at the University of São Paulo.